Hello, this is Dr. Nair, and we are going to work on the topic functional groups in this video. So in organic chemistry, you will find molecules with different functional groups. And what is a functional group? It is a group of atoms at a site that have characteristic behavior in all molecules where it occurs. Okay, so for example, it doesn't matter what the size of the molecule is or which organic molecule we have in hand. As long as you have that functional group, it will behave independently of the rest of the molecule. Okay, so it will have a predictable chemical behavior. So for example, in this two structures that you see, both of them have double bond, even though they are widely different compounds. One is ethylene and other is methane. When both of them are treated with bromine, Br2, you can see that the reaction at the double bond is the same regardless of what the structure of the molecule is, right? See, in the first case, you see that the bromine is added on to the double bond, and same thing here again, Br2, two Brs get added on to the double bond. So if the molecule possesses a certain functional group, then they will have a certain characteristic property, and that's what we are going to look at. Most of the organic compounds that you will see will possess some kind of functional group. Especially if you want to practice identifying functional groups, you can pick any drug molecule, because most of the drug molecules will have more than one functional group present in it. Okay, so for example, if you look at this is the structure of morphine, and it has several functional groups, and like this is an alcohol, this is a benzene ring, iodine ring. Here we have a cyclic ether, and we have an amine, we have an alkene, etc. Okay, so knowing the functional groups is really important in organic chemistry, and we will see the most important functional groups that you will need to know in this semester. So start with functional groups which contain just like the carbon-carbon bonds. For example, this one is alkene, so a double bond will be called as an alkene, and that is considered as a functional group. Alkynes, which is a triple bond, is also considered as a functional group. And then we have arenes. They have special bonds that are represented as conjugated or alternate single and double bonds. I'll redraw the benzene ring structure here. You can see that we have double, single, then double, single, and then double. So these are a class of functional group which we call it as arenes. The next one is the functional group halide, alkyl. We call them as alkyl halides, where you can also represent this in its general formula as RCl, where R is just used to represent a generic carbon chain. Okay, so this R can be any carbon chain, so it doesn't matter. It could be a ring, it could be a straight chain, as long as you have a halogen attached to it. So general formula for an alkyl halide will be Rx, where X is a halogen, and it can be chloride, iodide, bromide, or fluoride. Okay. Now, when we look at these examples that are given, you may also be asked to classify them as primary halide, secondary halide, or tertiary halide. So let's identify what would be a primary, secondary, and tertiary carbon atom first. Okay, and if a halogen attached to a primary will be called as a primary alkyl halide. A halogen attached to a secondary carbon atom will be called as a secondary halide, and for a tertiary carbon atom would be a tertiary halide. Okay, so I'll insert a new slide here and explain that. So a primary carbon atom would be somewhere. Okay, primary carbon atom would be a carbon atom that is attached to only one other carbon atom. Okay, so for example, if I take this structure, you can see that this carbon atom here is attached to only one here, right? So this becomes my primary. Do you see any other primary here? Yeah, look at this one. This one too, it is attached to only one other, so that's another primary. So we represent primary is in this way, primary, and then we have secondary, it's represented by 2 degrees, secondary, and then we have tertiary, which is represented as a 3 degree. So in this molecule that I have 3 primary carbon atoms because the ones that are attached to a only one more carbon atom. Okay, so we are representing that like a black ball. Now the secondary would be when a carbon atom is attached to 2 other carbon atoms. Look at this, the pink one, it is attached to 2 other carbon atoms. Okay, so that would be a secondary. And then a tertiary would be when it is attached to 3 other carbon atoms. Like in this case, we have only one tertiary, and we can see this is the green one, and that is attached to 1, 2, 3 other carbon atoms. So this will be my tertiary carbon atom. Now, if you take any of these functional groups and they are attached to any of these kind of these carbon atoms, then the name associated with will be like a primary halide or a primary alcohol, etc. Okay, so for example, since we are talking about halogens, let's redraw this molecule, and if my halogen was attached here, right, to the carbon atom which is tertiary, okay, this one is a tertiary carbon atom, right? So if the chloride is attached here, this chloride can be represented as a tertiary halide. Okay, tertiary halide, because it's a halogen and it's a functional group, so alkyl halides are functional groups, so this will be a tertiary halide. If it were attached to the secondary carbon atom, okay, here, if it was attached here, this will be called as a secondary halide because it's attached to a secondary carbon atom. All right, so that's about halogens. Moving on to the next one. The next important functional group is alcohol, where you have to see OH as part of the molecule in order to identify it as an alcohol. So any molecule that contains OH, see here we have an OH, that's an alcohol. Here we have an OH, this is menthol, also an alcohol. So this will be an alcohol functional group. Next, ether. Ether is when you have a general formula ROR. Okay. Again, remember R is just a generic carbon atom chain, which could be a CH3, C2H5, or a any alkyl group will be or any carbon chain. A generic carbon chain is what is an R group. Okay. So here we have multiple examples of ether where you can see that the oxygen, okay, single bonded, that's a key thing. Okay, you need single bonded oxygen atom to 2 R groups or 2 carbon chains. Okay, and sometimes you may see this in the form of a cyclic structure like this one. So the ethers can be cyclic ethers. There is an ether which we call it as epoxide. This is a cyclic ether where there are 2 carbon atoms. There are 2 carbon atoms here, and then there is an oxygen here. Okay, so as long as oxygen is single bonded to 2 carbon chains, that will be represented as ether. Ether is another common functional group. Next one is this carbonyl structures. Okay, so these all fall under one big umbrella of carbonyl groups. Carbonyl means where you have a carbon-oxygen double bond. That is mandatory in carbonyl containing functional groups. Okay, so I'll box them. See, here we have a carbonyl, here we have a carbonyl, there is a carbonyl, and esters, thioesters, amides, and acid chlorides. Okay, but the difference is they all have different groups attached to the carbonyl carbon. Okay, so we have aldehyde, ketone, carboxylic acid, ester, thioester, amide, and acid chloride. Okay, I'm ignoring thioester for this semester, but you will see that in the next semester. So we will keep it to aldehyde, ketones, carboxylic acid, ester, amide, and acid chloride under the carbonyl groups. Okay, so let's look that in a little more detail. So for an aldehyde, remember that we need the carbonyl as the main part of the functional group, right? So these are all under the carbonyl. So first one is aldehyde. In aldehyde, you will have the carbonyl carbon attached to an R group. Again, remember R is a representing just a generic carbon chain, but the other carbon will have a hydrogen atom. This is mandatory. Okay, so I will box the whole aldehyde identification group. This is a C double bond O attached to a single bonded hydrogen, and then this can be any R group It can be a carbon chain. Okay. Then next comes ketone. Now ketone can be a ketone is also a carbonyl group. Okay, so that is mandatory, your C double bond O. However, the carbon of the carbonyl is now attached to two R groups in a ketone. Okay, so that's the difference from the aldehyde. In aldehyde, you had a hydrogen, right? It had a hydrogen attached in one side. It's mandatory. So that has to be a hydrogen, and the other side can be R. But here you can have two R groups. Okay, you have two R groups. So this is ketone, right? Next one is let's look at what's in our carboxylic acid, right? So let's look at carboxylic acid. Again, we have the carbonyl mandatory in all of these structures. However, in carboxylic acid, you have one side as R and the other side has a OH. So this whole thing is the part of carboxylic acid. You need to have this set of atoms attached in this manner to be called as a carboxylic acid. So aldehyde, ketone, and now we have carboxylic acid. Then we have esters. Esters are also carbonyl compounds where you have C double bond O. In ester, you have one of the bonds with R, again a generic carbon atom, but the other side will have an oxygen which is then attached to another group. So let's highlight the characteristic of the ester functional group. This is what it is, the ester functional group. Okay, so maybe we can put colors here, right? So let's highlight all the functional groups in pink color. So this is aldehyde, identification of a ketone, a carboxylic acid, and here we have a ester. So you have to look out for these linkages of atoms in order to identify the different functional group. Okay? And then the next one we have is the acid chloride. Okay, acid chloride. Here again we have a carbonyl which is attached to a chloride, and then the other is a R group. So that's our acid chloride. Okay, this part. I think we have covered all of them. Amide. Okay, so one more is there under the carbonyl, and that is amide. Amide has a necessary carbonyl, that is CO, and then we have this as R, CO, and then it has to have connected to N. It can, so the nitrogen can be connected to two hydrogens, or it can be one hydrogen, okay, one hydrogen and an R group, or it can be two R groups. Okay, so these are different variations of the amide. Okay, so we have a the necessary condition for an amide is that it should be connected to a nitrogen atom, which can be again connected to two hydrogens, or to one hydrogen and an R group, or to two R groups. But you have to have this carbon nitrogen linkage, and then this should be a carbonyl. Okay, so among the carbonyl compounds, you should definitely have an idea of what these different functional groups are. Then we come to amines. Amines are, general formula is RNH2 if it is a primary amine. Again, now in this case, the primary amine means if the nitrogen has only one R group, if the nitrogen has two R groups and only one hydrogen, then we call it as a secondary amine. Secondary amine, this is a primary amine. And if the nitrogen has connected to three R groups, then we call it as a tertiary amine. Okay, so in amine, it's the classification is based on how many alkyl groups are replacing the hydrogen in ammonia. So it's derivatives of ammonia. See, this is ammonia. So as you start replacing each of the hydrogen atoms with a R group, and what is R group? It is a generic carbon chain. We call it as an alkyl group. Okay, so it can be an alkyl or it can be an aryl, but it has to be a carbon chain. That's important. Okay, so you can replace every time one of the hydrogen atoms with R group, and then you can classify them as primary, secondary, or tertiary. So NH2 or NHR or NR3. Okay, so these are the different amines. So in your textbook, you have a list of different functional groups, the most important ones we just discussed. And there is another one called nitrile. Okay, so that is RCN. Okay, that's cyanide. That is a nitrile. That is another important functional group you should know. And nitro. Okay, so RNO2. That's a nitro group. And these are the different functional groups that we expect you to know. So definitely alkenes, alkynes, and arenes. Then alkyl halides, alcohols, ethers, ketone, aldehyde, carboxylic acid, acid halide, ester, amide, amines, and then the nitrile and the nitro group. Okay. So the type of question you may be asked is something like this, where you may be given a bunch of molecules and you're asked to identify different functional groups in them. So for example, you look at this structure and you see that you have a arene here, right? So that is an arene. You have an NHCH3. If you recall, that is going to be your amine. Okay, whenever nitrogen is connected to either two R groups or two hydrogens or one hydrogen and an R group, that will be an amine. And then see here we have a alcohol, right? So there we have alcohol. That's structure A. Now look at B. B has two functional groups. It's an alkene here, and you have a ketone here, right? So that's how you will go about identifying different functional groups. If you look at this one, you have an alkyne and you have an acid chloride. Right? You have an acid chloride here. So these are the two functional groups that are present in this molecule. Here we have a carboxylic acid, and also we have an amine. See, we have an amine. So most of the pharmaceutical compounds or drugs which you take out, you will see multiple functional groups in it. So the best way to practice is just pick a few pharmaceutical drug molecule structure and then identify different functional groups in it. And here we have an amide here. See, as long as you have a carbonyl connected to a nitrogen, that's an amide. Here we have a ketone. Here is an alkene, two alkenes here, okay, and so on. Sometimes you may be asked to draw a structure with different functional groups. So for example, I ask you, can you draw a organic molecule having 3 carbon atoms and having ketone functional group? So go ahead and draw 3 carbon atoms and then put a ketone functional group. Or if I ask you draw a molecule with 3 carbon atom which is an aldehyde, so in that case you can do 1, 2, 3. Remember, in aldehyde you need to have this as your function group, right? So that will be your aldehyde. This will be a ketone. So practice identifying functional group, because this is one of the key topics in organic chemistry. Hope to see you in the next video.